Alrighty, hello. Today we're going to be finding the difference between two functions, f of z and g of z. Now these are given to us. F of z is our 10z to the third plus 10z plus 3, and g of z is negative 5 minus 7z to the third plus 13z. Now all we need to do, we're asked to find the difference. Difference just means subtraction between them. If it was a sum, you would just add, you would combine your like terms and you'd be done. Now difference needs to work a little bit differently here. Alright, so it says f of z, which we know is the 10z to the third plus 10z plus 3. We know that is f of z. It's literally given to us. So our f of z minus g of z is going to be our f of z minus our g of z. Now what needs to be around our g of z here is parentheses. Right? As soon as you see that subtraction, you should be thinking parentheses matter here. Alright? And the reason why is because you're not just subtracting the 5, the negative 5, right? You're not just subtracting that. You're not just subtracting the negative 7z to the third. You're subtracting all of it. And those parentheses tell you that all of it's getting subtracted. Alright, so now what we need to do is we need to bring that subtraction through. So your 10z to the third plus 10z plus 3. And then we say, okay, subtracting a negative number. Well, what's a negative times a negative? A positive, so plus 5. Subtracting a negative, z to the third, is plus 7z to the third. And then subtracting a positive is just negative 13z. So that is now, you've now brought the subtraction through the problem and you're good to start going. Alright, now you need to look for this and say, alright, what are my like terms? Well, I usually start with the highest power, which we see here is a 3. Is there anything else with a z to the third? Yeah, there's 1. Okay, now if there wasn't any, you would just bring it down. So 10 plus 7, 17. Alright, now you start with the next highest power we see. That's going to be just a plain old z. And we have 2 of them. You have 10 and negative 13. When you combine them, we get negative 3. So negative 3z would be our last one. Because now you'll notice that we have 2 things, the 3 and the 5, without a z attached. Well, those are just numbers. Numbers combine like numbers should. Plus 8. Alright, and that is your polynomial. It's simplified, it's done, you're good to go. Alright, let's answer some vocab. So, degree of the polynomial is really just saying, hey, what is the highest exponent possible here? Well, the highest exponent on our problem is a 3. That's the degree of your polynomial. Now, the degree of the polynomial versus degree of terms are two different things, right? The polynomial is the highest exponent out of everything. Degree of the term refers to one specific piece of the polynomial. Alright, so next, leading coefficient. So the leading coefficient is going to be looking at the number in front of the variable with highest exponent, which we already know the highest exponent here is z to the third, right? 3 is the highest exponent, and the number in front of it, 17. Lead coefficient. So now we look at this next one. It says, what is the coefficient of the term with degree 0? Well, that is actually going to be 8. Alright, you'll notice that here, on our other two, we have a z and a z. Right? There is a z there is a variable there, but there's nothing here. Technically, whoops, not x. Technically, this has a z to the 0th power attached to it. This is an exponent property that anything to the 0th power is 1. So it's essentially saying 8 times 1 there, which is just 8. It doesn't change anything, right? And that's why we call it degree 0, is because of that exponent property. Alright, so that is your coefficient of the term degree 0. Last but not least, we have the classification of the polynomial. A reminder, alright, this first one is looking at the degree of the polynomial. Alright, this next one is looking at the number of terms. So I'd say, all right, degree of the polynomial we said was 3. Well, these just go in ascending order. Constant is degree of 0. Linear 1, 2, 3, 4, 5, so on and so forth. Same thing here. Monomial. Mono means 1, so monomial is a polynomial of 1 terms. Or 1 term, I should say. All right, so here we have a 3, which is a cubic. Oh, I meant for a highlighter on that. I got a cubic there. And then the number of terms, well, we have 1, 2, 3 terms, right? A term is separated out by addition and subtraction, which means 3 terms would make it a trinomial. So the classification of this particular polynomial is a cubic trinomial. All right, that would be all. Thanks for watching.